Good morning, students. Our today's topic of discussion is joints in rigid pavement. In the last class, we were talking about the critical combination of stresses, and we found that it is the warping stress which causes the different kinds of relative movements in the rigid pavement, which is the very reason why we need to provide the joints in case of the rigid pavement, so that the rigid pavement can relatively move in an easier way. When the expansion and contraction joints are properly designed and constructed, there is no need to providing warping joints. In addition, however, the contraction joint spacing design is governed by the anticipated frictional resistance and allowable tensile stress in case of the concrete. We will be understanding the facts in the coming few slides. So here we can see that joints are provided for the movement. Obviously, these are the relative movements while safely absorbing the temperature-induced expansion of conduction. That means when the temperature is high, expansion will take place, and when the temperature will be low, the contraction will take place in the concrete slab. Also, there are few factors which can actually make the concrete slab move. That is vibration due to the wind load or movement of ground due to settlement or any seismic activity like the earthquake. Obviously, in this picture, you can see the basic components of the concrete pavement. So here, the main thing is that we need to see that in both the direction, that is in the longitudinal direction where the vehicles will be moving, some joints are provided in the longitudinal direction, that is known as the longitudinal joint, as well as in the transverse direction or in the cross-sectional direction, some joints are also provided. So in all these cases, these joints will be attached with few of the bars. They are known as the dowel bars and as well as the tie bars. Obviously, we will try to understand these facts in our next few classes. So, what I have said, as the temperature increases or drops, that is decreases, the concrete pavement expands or contracts. The pavement's relative movement is resisted by the subgrade friction. That means when the slab is trying to move, the subgrade will try to fix it in the same position as it was in the previous occasion. So this creates the stresses in the concrete slab. Now, in order to make this movement flawless, we need to provide the joint. Now there are various types of joints in concrete pavement. That is the contraction joint, construction joint, expansion joint, and working joint. The functions of the joints are following. First of all, the contraction joint, it is very simple that when the contraction takes place, the contraction joints are provided along in the transverse direction, that is in the cross-sectional direction of the road, to take care of the contraction of the concrete slab due to the shrinkage. Next up is expansion joint. It is provided along the transverse direction again to allow the movement of the concrete slab. Here I have written allow the movement in case expansion or contraction. Both things can happen in case of the expansion joints when they are provided because of the fact that the temperature and the subgrade moisture variation will come into picture. When the temperature will change, the slab will try to expand, but when the subgrade moisture will vary, then expansion as well as contraction may happen. So in case of the contraction also, for the subgrade moisture variation, we used to provide the expansion joint. Next is the construction joints. Obviously, they are provided whenever construction work stops temporarily. Why temporarily? Because after the end of the day, when the construction work will be finished, and on the next day, new construction work will be starting, on those occasions, these construction joints are actually provided either in transverse or in the longitudinal direction, depending upon the progress of the work. Last up is the warping joints. They are provided along the longitudinal direction to prevent the warping of the concrete slab due to the temperature as well as the subgrade moisture. So warping joint the longitudinal direction, and in case of the expansion joints, they are mainly provided in the transverse direction. Now, what may actually happen if there was no joints provided in the concrete slab? In the left side, you can see the unjointed pavement. That means if a concrete slab was continuous and like this. So when different kind of moisture effect, the temperature effect, as well as the soil load will come into the picture, this could have caused some crack. But here, properly jointed pavement, in case of the joint, they will not provide show you any kind of crack at the very beginning. So that is why when the joints are provided, this allows this panel of the slab to have these panels will be able to move in either direction. Now there will be two kind of equations, the spacing of the expansion joints. If delta is minimum expansion of the slab of length LE with temperature rise from T1 to T2 in degrees Celsius obviously, then delta minimum expansion equals to LE into C into T2 minus T1. Why I have written here as LE? Because of the fact that it is the rise in temperature and some length has been provided in case of the expansion joint. So E means expansion. So this is the equation from where you can easily find the expansion joint spacing. That will be LE. Okay. Expansion joint spacing in other words means the length of the slab when the expansion joints are provided. That means between two consecutive spacing there will be a slab. So the spacing of expansion joints means the consecutive spacing between them is the length of the slab. As per the IRC recommendation, this gap should not be more than 2.5 centimeters in any case. Obviously, there is another factor in this equation, that is the capital C. It is the thermal expansion of concrete per degree rise in temperature. Next up is the spacing in construction joint. Now, the slab contracts due to falling temperature, you can easily understand that. But why I have provided this picture? You can see that subgrade layer is there, and over that base as well as the surface layer or the concrete slab is there. One load transfer mechanism is there, that is the dowel bar that we will be discussing in our next class. Now, what actually happens when the contraction takes place, the frictional force will try to move that slab to its basic position, to its normal position. So the frictional force is from middle to this side, it will act in this side, and from middle or the right side will act in this side. So what actually happens, the maximum intensity occurs at the midway of the slab in this particular region. So if LC is the spacing between the contraction joints, then LC is equal to 2S into 10 to the power 4 divided by W into S, where these are the notations of different things. Also, if RCC is provided, that is along with this dowel bar, if RCC is provided in either of the slabs, then the equation will change some like LC equals to 200 into S1A divided by LC equals to 200 into SA into A, S1 into A divided by VHWS, where the slab width is the slab thickness, S1 allowable tensile stress in steel, A is the area of steel, and obviously LC is the length of the contraction. Okay, so that's it for today. Obviously, in the exam, some different numerical examples will be coming using these two formulas. They are having a similar kind of meaning, but at the same time, we need to remember that they will be carrying different kind of properties. One for the PCC, that is the plain cement concrete, and this one for the artificial reinforced cement concrete.